All right, so today we are looking at Chapter 10, Section 4, which is called Inscribed Angles. So in the last section, we talked about central angles, and if you will remember, so if I draw a little circle here, let's move it over. So a central angle, so if the center of my circle is about here, and mine will be a little bit off. So if I were to draw a central angle, the central angle is this angle here. So we'll call this central angle, and this will be circle A. So this central angle and this arc right here that it intercepts are equal to each other. So if this angle, if this is a 50-degree angle, then this is a 50-degree arc. So central angles equal their arcs. Okay, that's what we learned in the last section. Today we're going to take a look at what's called inscribed angles. Inscribed is because the angles are inside. So here we go. Oops, back up. All right, so how are inscribed angles related to their arcs? So they're not going to be equal like central. They're going to have a little bit of a difference. So an inscribed angle, by definition, is an angle whose vertex is on the edge of the circle, okay? So I'm going to type that where it's not unreadable. So definition, inscribed angles are angles that have the vertex on the circle's edge. Okay, so for example, these are all inscribed. So you see this angle right here, and let me use a better color. It's the same color. All right, so if I were to look at this angle right here, see how the vertex is on the circle? This is the arc angle. See how it's on the edge of the circle? So if you trace it, you can see the arc. The vertex is on the circle, so trace the edges, and here is your arc. This is not inscribed. It's just floating around inside. This is outside. So these are not inscribed angles. These are. The vertex has to be on the edge. All right, so it says to highlight the angle yellow. So what I'm going to do is go in here and highlight the angles yellow. So let's use the highlighter and let's use yellow. So we're going to highlight the angles. So this is angle ABC, so they want this angle here. So we looked at that angle. So now we're looking at angle B. Angle DEF, so DEF is this angle right here. And XOY, so XOY, so they're wanting this angle here. All right, step 2, circle the vertex of the angle. So let's circle the vertex. So let's circle the vertex, circle the vertex. All right, and highlight the intercepted arc pink. So now we're going to go back here and highlight pink. So the arc that I'm highlighting is pink. So notice this, I should have done this here. What I should have done is traced out the sides of the angles yellow instead of coloring them in. So we'll do this real quick. So we've highlighted those, and now you connect the ends. Those yellow ends, connect them with the pink. Okay, so these are all inscribed angles or central angles or one of the two. So now let's go back here. So is this inscribed or central? Well, since the vertex is on the edge, it's inscribed. Angle B is on the edge, it's inscribed. Angle E is on the edge, it's inscribed. This angle is at the center, so it's central. So remember, if it's at the center, it is central. All right. So now, how do you find the measure of the angle if it's central? Well, if it's central, we know it's equal, right? Well, if it's inscribed, there's this beautiful little formula. So the measure of an inscribed angle, so the measure of the angle is equal to half the arc. So the measure of angle ADB, so if I trace it out again, let's see, just going to do this real quick. Work with me here. So if I trace the angle in yellow and then highlight the arc in pink, so you see what angle and arc we're talking about. So the measure of this angle right here is equal to half of the arc that's pink, which would be AB. So its measure is half of arc AB. And make sure you're familiar with the arc. So we have an angle symbol and an arc symbol. So always look for the vertex of the angle. So given circle C, so it's called circle C because C is the center. So what angle is half of what arc? So if you look over here, we trace it out again. So we're talking about this angle. So I'm going to go ahead and color the pink and the yellow. So the angle is WTV. So WTV, and it's half of arc WV. Notice that the two sides, the angle ends, and that's the name of the arc. So in part B, it says, given that the arc is 80. Well, if the arc is 80, well, we know that the angle is half of the arc. So what is half of 80? It is 40. So that means this angle is 40 degrees. So all you got to do is just take half. So if you're inside, it's smaller. If it's outside, it's bigger. So now this one says the measure of arc, JOE, is 200. It's 200 because it is a major arc. So J to O to E. So this whole arc is 200. So the measure of angle JED, J to E, out here to D, so they're talking this angle. Well, this angle is half of this arc, so it's half of 200, so that makes it 100 degrees. So if this angle right here is 100 degrees, what is the measure of the other arc? Because there's two arcs in this picture. So we have this arc right here also. Well, how many degrees are in a circle? So if a circle has 360 degrees and the major arc is 200, then we have 160 degrees left over. So this arc is 160 degrees. So you can find out a little bit about both. All right, so now we're going to look at this picture over here, and we're going to use the diagram to find the indicated measures. All right, so what we learned before is this is a diameter, and it cuts a circle in half. Okay, so what we're going to do is see what we can figure out. So it says, what is the measure of angle A? Well, if you look here at angle A, if you trace it out like this, just kind of extend your sides a little bit. So that would be this arc right here. So it's half of this arc right here. I feel like I missed something. Give me 1 second. Okay, I feel like those should have come first. All right, so let me skip over here real quick because we need to talk about these theorems first. Okay, so if you have two inscribed angles in a circle and they intercept congruent arcs or the same arc, then the angles are congruent. So let's just say, for example, so let me get the highlighter. All right, so if I were to highlight this angle right here, and then here's the arc that it uses. So I know that SMR is half of SR. But then if you look at this angle right here, it uses the same arc. So that would mean that, let's say this arc was 40 degrees. So if this arc is 40 degrees, then I know that this angle is 20 because it's half. Well, if this angle is using the exact same 40-degree arc, then that makes this one 20 also. So that means that angle SMR is equal to SAR. So as long as they share an arc, they're going to be equal to each other. Same thing if you looked at the two angles that are using this arc right here. So if I were to MSA uses MA, same thing. Okay, another instance here is if an inscribed angle intercepts a semicircle. So if I were to look at, I think I loaded my two slides backwards, I apologize. So this angle right here is using this arc. Well, since this is a diameter, I know this is 180 degrees. So this is inscribed. So this angle is half of this arc. Well, what's half of 180? It's 90 degrees. So this is a 90-degree angle. So every single time you are drawing your inscribed angles, always double check to see that the sides aren't going over the ends of the diameter. Because if it goes over the ends of the diameter, this will always be a right angle, no matter what. So always look for that because it makes it really simple. And then if you have a quadrilateral inscribed, then the opposite angles are supplementary. So angle A is opposite D. So A and D are supplementary. So angle A plus angle D equals 180 degrees. And then N and L are opposite. So angle N and angle L are supplementary. So angle N plus angle L equals 180 degrees. All right, so now let me go back to here so we can find these measures. So first off, what I'm going to do is do my highlighting. So if I'm looking at angle A is right here. So I notice that as I draw angle A, that the angle goes to the ends of my diameter. So that automatically means that this is 180 degrees, so this is 90 degrees. So angle A is 90 degrees. Well, we know that angle B is 28, and I know that angle B plus angle C have to add up to 90. So if B is 28, so 28 plus C equals 90. So what is 90 minus 28? So angle C is 62. So angle C is 62 degrees. So I'm going to go up here. Make sure this is 90. So this is 62 degrees. But that means this is a right triangle also. So since ABC is a right triangle and I know two sides, and I can do Pythagorean theorem to get BC, which is my diameter. So 3.9 squared plus 7.3 squared, and then take the square root. So 3.9 squared plus 7.3 squared, and then take the square root of that. get 8.3. So my diameter is 8.3. These are supposed to be arcs over here, and they always get left off. So now what is the measure of arc AC? So if I go up here and I'm looking for this arc right here, this arc belongs to angle B. So angle B is 28. So if the angle is half the arc, then that means 2 times the angle is equal to the arc. So if you're looking for the angle, take half. If you know the angle, multiply by 2. 2 times the angle equals the arc. So that means the arc is 56 degrees. So this is 56 degrees. So 56 degrees. Well, remember that if this arc over here is 180, because it's a semicircle, then this half is also 180. So now they want us to find the measure of arc AB, which is this arc right here. So this is going to be 180 minus 56, because from here all the way around is 180, and we know 56. So 180 minus 56 is 124 degrees. So these are the two formulas for this section. The angle is half the arc. 2 times the angle is 1 arc. All right, so we're going to circle the vertex of the angle. We're going to determine the central. We're going to determine if it's central or inscribed. If it's central, remember the arc is equal to the angle. Arc is equal to the angle. If it's inscribed, the angle is half the arc, or 2 times the angle equals the arc. So let's see, circle the vertex. So here's the vertex. This one is inscribed, so I'm going to put an I for inscribed. Here, I'm going to do it again. I'm going to circle the vertex. This is inscribed. Find the value of all the variables. This variable should be down here. I don't know what happened there. So let's find all the variables. That kind of got off kilter a little bit. So they want this angle right here, which is inscribed. And then we have the arc. The measure of angle 1. Angle 1 is right here. So this is inscribed. And then this angle right here is also inscribed. So we are going to use this rule. So I know that the measure of the angle is equal to half the arc. So what is half of 115? So 115 divided by 2. So x is 57.5, and that would be degrees. This time I know the arc, so I know 2 times the angle is equal to the arc. Oops, I'm going to backtrack on that. Can I erase this? There we go. Sorry, I was looking ahead. All right, so we are going to, so we know the angle, which is x, is equal to half the arc, which is 90. So x is 45 degrees. I will never understand why it always gives me a pen or an eraser when I'm trying to write with a pen. All right, so here I'm going to trace out, so angle M is that angle there, and this is the arc. But what I do notice is that this 43-degree angle uses the exact same arc. So that means that if the angle is 43, then double that, because 2 times the angle is equal to the arc. Well, if this is 43 degrees, then I know this one is also 43 degrees because they share the same arc. So M is 43 degrees. 2 times 43 is equal to the arc, which is N. So 86 is equal to N. So the arc is always 2 times bigger. Right here, they want me to find this angle, but this angle uses this arc, and I don't know that arc. But what I do know is that there's 360 degrees in a circle, and I have 120 and 80. So 120 plus 80 is 200. So I'm going to subtract 200, and I get 160. So this arc is 160. So we know that angle 1 is half of 160, which is 80 degrees. All right, so let's do one more. So I know that the rule is the angle is half the arc. Well, my angle is 3x minus 3, and that's half of the arc, which is 120. So 3x minus 3 is equal to 60. So add 3 to both sides. Oops. So 3x equals 63, and then divide by 3. 63 divided by 3 is 21. So x is 21. And that is all of 10.4. You'll be looking at 10.5 next.